Hello, and today's learning target is I can solve and graph a one-step inequality. First, let's define what an inequality is. An inequality is a mathematical statement that uses less than or greater than to compare two values where an equation would use an equal sign. So let's go back and fill all that in. An equality is a mathematical statement. So I'll zoom in and then I'll go ahead and write statement. That uses less than or greater than to compare two values where an equation would use an equal sign. So an example of an inequality could be x is less than 3. So this means that all of the solutions to this statement could be either 2.9, 2.8, 2.6, 2.7, everything less than 3, but it just cannot be 3. So now let's take a look at graphing inequalities. So we can graph a solution to an inequality on a number line. Let's graph the following numbers on a number line. So here for this first example, I see x is greater than 5. So all solutions that are greater than 5, but not including 5, would work for this statement. So I'm going to draw a number line. I'm going to put 5 in the middle. I'm going to put two numbers larger than 5 to the right of it, and two numbers smaller than 5 to the left of it. And then to graph x is greater than 5, I am going to put an open circle at 5 because this graph does not include 5. And then I'm going to shade everything to the right of it because everything to the right of 5 is greater than 5. So I'll shade to the right, draw an arrow, and I like to change colors so you can see that the actual graph I made on the number line. So this would be the solution and the graph for x is greater than 5. Now to graph x is less than 5, very similar. I'm draw my number line, put 5 in the middle, two numbers greater than 5, and two numbers less than 5, and I always like to put numbers right next to the value that I'm actually going to graph, just because it's simple. And then I will have an open circle at 5, and everything less than 5 would be shaded. So I'll shade to the left because that denotes everything, every number or value that's less than 5. Now as we take a look at the greater than or equal to example, so x is greater than or equal to 5, this is a little bit different. This means all the solutions greater than 5, but also including 5. So this will be a little bit different. So I'll put 5 in the middle, 6 and 7, 4 and 3. And then now, to denote that 5 is an actual solution, I don't have an open circle. I have a filled in circle at 5, which means that that is also a value that works for this statement, which is also a solution. But I'll still shade everything to the right because everything greater than 5 still is also a solution, including 5. Very similar, x is less than or equal to 5. I'll put 5 in the middle, 6, 7, 4, 3, and then I'll put a closed circle at 5 and shade to the left because less than 5. And that's how to graph an inequality on a number line. So in conclusion, if it has a line underneath, we have a closed circle. And if it does not have a line underneath, we have an open circle. So with that inequality statement. So here this will be closed, and then the second one will be open. Okay, let's move on. So let's take a look at this first example. X plus 8 is greater than 4. So I'm going to solve this inequality, and I'll zoom in, like I would solve an equation. I want to isolate the variable, and I can also draw a line down where the inequality is instead of an equal sign. So draw a line down, and I'm going to isolate x, so I'll subtract 8 to both sides and get x is greater than 4 minus 8 is negative 4. So my solution here is x is greater than negative 4. So everything greater than negative 4 would be a solution. So if we were to graph this, and I won't graph all of these examples just to save time, but you will see graphs on a future quiz. So we have to make sure we still know how to do these, but I'm not going to do them for every example. But I am going to graph this one. So I'll put negative 4 here, negative 3, negative 2, negative 5, and negative 6. And then I'll go ahead and put an open circle at -4, and I want everything greater than -4, so I'll shade to the right. And then that would be my solution and my graph. Okay, let's look at another example. 3 is greater than v divided by 3. So to isolate the variable, I have a division of 3, so I'll multiply by 3 on both sides. And 3 times 3 is 9 is greater than v. And we can leave our answer like that, but it's always proper to write the variable first. So I'm going to flip that around and write the variable first. And so this would be v is less than 9. So not only did I flip the inequality, but I also changed around where the variable and the number was. And both mean the same thing, but it's proper to write with the solution with the variable first. So v is less than 9. Okay, let's continue. X minus 6 is greater than -4. And I'll go ahead and solve this example. So I'll add 6 to both sides. And -4 plus 6 is 2. So x is greater than 2. Okay, let's continue on. 2 is greater than v divided by 3. So again, I see a variable and then a division symbol with it. So to undo division, we'll multiply by -3. So then -3 times 2 is -6. Can't write with this stylus right now, so -6 is greater than v. And again, it's proper to write your variable first, so we can go ahead and flip those around and get v is greater than -6. Okay, let's continue. Go back up to the top. Okay, let's look at our next example. -5x is less than or equal to 10. So I will draw my line, and I'm going to divide by -5 here. And when I divide by a negative with inequalities, we have to flip the inequality symbol. And this rule only applies when you multiply or divide by a negative. So I get x is greater than or equal to -2. Let's fix that. And now one thing I'm not doing is I'm not plugging my answers back in to make sure that they work. However, we will go over a few of these examples in class to double check the work, but again, it's just like equations. You plug your value of your number back in for your variable and make sure that the inequality statement is true. Okay, I see -3 is less than or equal to b minus 3. So I will go ahead and I will add 3 to both sides. Sorry, the stylist isn't, or the screen isn't sensing the stylist. So -3 plus 3 is 0 is less than or equal to b, but it's proper to write your variable on the left-hand side. So we'll go ahead and we'll say b is greater than or equal to 0. And that actually is a solution. It's not no solution, it's just 0 is the solution. All right, 2x is less than or equal to 4. I will divide by 2 and get x is less than or equal to 2, and no dividing by a negative, so that's my answer. Some of them are really pretty simple, but let's look at this last example. I'm going to go ahead and subtract 5 on both sides, and then I get -5 is less than or equal to -b. Now I cannot have a negative variable, so I have to divide this b, -b, by a -1, or simply just a negative sign. And -5 divided by -1 is just 5. So this is 5 is less than, greater than or equal to b, because I cannot have, or when I have division of a negative, I have to flip the inequality sign. I cannot leave it as it is. And then this variable is not written on the left-hand side, so I need to flip that to the other side. So I get b is less than or equal to 5. Okay, and then let's go ahead and look at the rule. When multiplying or dividing by a negative, we must flip the inequality. So an important rule that we cannot forget. So now let's take a look at what types of words or phrases would mean or would represent certain inequality symbols. So let's look at the first question. What words or phrases would mean greater than? Well, a couple words or phrases that would mean greater than are, and I'll zoom in here, could be is more than or is greater than. So there's a couple. Is more than and is greater than. And if you have a few more, feel free to jot them down and we can share them with the class. And I'm sure we'll think of more as we come upon them. The next question is what words or phrases would mean less than? Well, we could say is less than, right? If we see those words, is less than, is smaller than, is fewer than, and with saying is fewer than for the less than, we could say is bigger than for the greater than. Okay, let's continue. What words or phrases would mean greater than or equal to? So remember, when we have greater than or equal to, that means the number that we see or bigger, right? The number that we see or bigger. So we could say, something like, Miss Roddy is at least 5 feet tall, which means that I could be 5 feet or I could be greater than 5 feet. And I am definitely greater than 5 feet tall. But anyway, so saying at least, that would be a phrase that would mean greater than or equal to. Now, what words or phrases would mean lesser than or equal to? Well, we could say, the child can have at most 2 cookies. Well, this means that they can have 2 cookies or 1 cookie or 0 cookies, but you can't have more than 2. So we could say for what would mean lesser than or equal to would be at most. So you can have that number of cookies or everything less than that number. Now let's take a look at writing inequalities from the following statements and solving. So the first one, the sum of 5 and x is greater than or equal to -2. Well, we know the sum means plus, and greater than or equal to is this statement. So if we put those together, the sum of 5 and x, so we could say x plus 5 or 5 plus x would mean the same thing, is greater than or equal to -2. Now we'll subtract 5 and solve and get x is greater than or equal to -7. Let's look at the next example. The product of 2 and y is less than -18. So the product means multiply, so 2 times y is less than -18. And to solve for y, we'll divide by 2, so we get y is less than -9. Now, don't get confused here. We don't flip our inequality sign because we did not divide by a negative. Sure, our answer ended up being negative, but we divided by just 2, so that answer is not, so that inequality is not flipped. Our answer is just simply negative. All right, in the last example, the quotient of y and 8, so that means division, so y divided by 8 is greater than -5. Times by 8 to get rid of the division of 8, and we get y is greater than -40. So, just to recap, this page was all about looking at phrases and translating them into statements, or just knowing, what type of phrases would go with what type of inequality symbols. We also reviewed graphing and solving one-step inequalities as we start our inequalities unit. Thanks for listening and have a great day. Bye-bye.